Hello everyone and welcome to the video on Introduction to Data Analysis with Python. My name is Suman and you're watching VIT CSC Promotions. In this video, we'll be taking you through the basics of data analysis using Python, a powerful programming language widely used in the data science community. Data analysis has become increasingly important in today's world, where organizations and individuals have access to vast amount of data. With the help of data analysis, we can extract valuable insights and make informed decisions. And Python is a very great tool for such data analysis due to its simplicity, flexibility, and extensive library support. So in this video, we'll be covering the following topics. First up, we'll be having a brief introduction to data analysis, and then we'll be covering the applications of data analysis and the requirements as well, and how to install Python and its related libraries, and the key concept of exploratory data analysis. We'll also provide a step-by-step coding tutorial to give you a hands-on experience in analyzing data with Python. Let's look at the introduction to data analysis. Data analysis is formally defined as the process of inspecting, cleaning, transforming, and modeling data with the goal of discovering useful information, drawing conclusions, and supporting decision making. It involves using various statistical and computational methods to extract insights from data and make data-driven decisions. So using data analysis, basically you can convert all the raw information available, it may be customer data or financial data of an organization or whatever it is, and make some decisions by analyzing the data, which might be useful in the long run. Coming to the applications of data analysis, data analysis can be used nearly in every field possible where data is available. So data analysis can be used in identifying patterns and trends in data, such as in stock markets or even business accountancy as well. And it can be used for finding and fixing data quality issues. So certain times there might be an accounting issue or whatever it is, and data analysis can help fixing those as well. And data analysis is also used for conducting research. So there might be a large survey data which might need a lot of processing as well. So data analysis will come handy over there. And many surveys and other such user input can be used to improve and optimize business processes. So data analysis is a very good tool over there. So coming to requirements for this particular video. So I expect the viewers to have a basic understanding of programming constructs such as the fill statements, for loops, while loops, and etc. And it's better if you know the general principles of statistics, and interest in data science is also a very important factor over here, because you'll be dealing with a lot of data which might seem monotonous sometimes. And basics of Python is always appreciated, as we'll be coding along in Python. So coming to the installation, so we need the following softwares or libraries to be installed on our system to go further ahead. So which includes Python, Jupyter Notebook, Matplotlib, Pandas, Seaborn, and NumPy. So let us have a look at how to install such software. So here, so to install Python, you can just go to your browser and search for Python, and the first result will be from the python.org. So you can just go to the download latest version and download this. I've already downloaded the file, and so we can just go to install. So you just open this file which is installed, and since I already have Python installed in my system, it asks me to upgrade now, which will be a bit different for you. So I'll choose custom installation. So you can click on all these following and hit next, and then when you're about to finish it, there is a particular checkbox for add to path, so which I recommend to select as well. And then next up, we'll look at the other libraries to be installed. So first up, we'll install Pandas, Matplotlib, Seaborn, and Jupyter Labs. So I'll be using Jupyter Labs, so you can feel free and try any Python-based IDEs or any other code editors as well, such as Visual Studio Code and any other ones, Atom, etc. So let's have a look at how to install the software. So here, so just to verify that you have installed Python and everything is fine, just you can type the command Python and you will have the interactive shell over here. So to exit the interactive shell, you can just press Ctrl Z and hit enter. So to install our packages, all we have to do is pip install. So first off, we need pandas. Then we also need matplotlib. We also need cborn, and we'll be also using numpy. So type the following command and hit enter. So this will install everything, and since I already have everything installed, it says requirement already satisfied. So which may not be the case in your situation. It will install after a few minutes. So after this, so you can start the Jupyter notebook. Oh, okay, we haven't installed Jupyter notebook. Sorry for that. Okay, sorry for the interruption. So pip3 install Jupyter Labs. So this will install the Jupyter notebook, the Jupyter lab, and all the other things. So and once the installation is done, you can start the Jupyter notebook by typing Jupyter Labs, or you can go with Jupyter Notebook, which will open a Jupyter Notebook application. So I'll be doing Jupyter Lab. I'll be using Jupyter Labs today. Sorry. So I'll be using Jupyter Lab today. So I've already opened a new notebook. So for opening a new notebook, all you have to do is hit the plus icon over here. So and click on a notebook Python 3, and it will open a new notebook for you. So I don't need this. I'll be discarding it. So coming to our next, we look at exploratory data analysis. So coming to exploratory data analysis, it is a method used to analyze and summarize data sets. EDA involves statistical techniques and visualizations to gain insights into the data and identify patterns, trends, and outliers. So it's an iterative process. So being that for each and every data, what you find in the data set, it's more of a trial and error approach where you can just choose what factor you are weighing in and try exploring what the data contributes to. And then it's more of a preliminary step so that you can move on to advanced statistical analysis or even apply machine learning algorithms. So EDA is particularly useful when you're dealing with a very large and complex data sets, and it can reduce the data dimensionality and highlight the most important features. So because during EDA we'll be eliminating certain columns and certain rows, so it will be really helpful because data at certain times can involve like millions of records, so which will be very difficult to handle if we don't do certain processings and cleanings. So next up we'll have a brief coding tutorial. So let's move on to our Jupyter notebook. So now that we are in our Jupyter Labs, let's just look at our dataset. So this dataset is basically a mutual funds dataset, which consists of the scheme names, the fund managers, and all the SIP details and all the other stuff which are important with respect to mutual funds, and it also contains the MC names and other stuff as well. So let's begin our data analysis by importing all the modules which we require. So first we'll import our NumPy, Pandas, cborn, and Matplotlib as well. And then I'll just press Shift Enter, which is a keyboard shortcut to run the particular cell and go to the next cell. Next, we'll just have a look at what current working directory we are in. So sometimes what happens is that when you're running your Jupyter Labs, you might be in some different directory, and so whenever you give some file path names, so it will not work as it is. So as far as our current directory, it is we are in documents. So let's start reading our CSV file. So let me declare a variable called df. So using our pandas, which has a read CSV method, we'll just enter the file name, which is comprehensive data.csv, and on running our data will be red. The CSV file is red. So just to look at our initial data size, so I'll do df.shape, which will give me the shape. In the sense it will tell me the number of rows and columns. There are about 814 rows and 20 columns right now. And then just to check out a few values in our data set, we'll just do df.head. So which will give me a brief outlook of the first four entries within our data frame. So this is our data frame. So this is useful when you want to look at our data frame in like what our data frame consists of. Then we'll just have a brief infographics of our dataset by df.info, which is again a built-in method in the pandas data frames. So here we can see all the list of the columns in our data frame and the count of all the non-null values and the data type of each of these particular columns. And then we'll just also look at another built-in function called describe. So this will just show me the gross statistics of each of the columns. Each of the columns in the sense all the numerical columns, so such as expense ratios and fund size, etc. So if I just show you in the df.info, all these numerical data types will be present over here with their mean, standard deviation, and it's all the other statistical values. So next important step during data analysis is to see if there are any null values in the data set, so that we can just eliminate them or deal with them in some using some strategy. So we'll just check whatever is null in our data frame and do the summation of it. So the sum will give us the count of all the null values. So here, as we can see, the 3-year returns and 5-year returns has null values. So we need to deal with that because without them, our statistical analysis will be a bit inaccurate. But it's better if we deal with it right now. Also, coming to our data set, let me show you an example. So if we can look at the alpha column over here under row 8, so there is a dash over here which represents a null value, but it is in a dash form. So we need to eliminate these as well. So in order to do that, I'll just use the replace command of the data frame and just hit execute. Now we can see that all the rows which had dashes as well is now replaced by not a number or which is a null value. So now we can go ahead and eliminate all the null values. So first up, we'll just define all the columns in a particular array, and then we'll just start eliminating each of these using the following statements. So here for each of the columns we are converting them to a uniform float value, and then in the second line we are finding out the mean of each of these, and then in the final statement we are just filling all the null values with the mean values of each of these Sortino, alpha, standard deviation, beta, and sharp columns. Okay, I had missed a bracket, sorry for that. Now we have to also remove all the null values within the 3-year and 5-year returns, so which will be the same as this command, but instead we'll be using just the 3 years and 5 years instead. So similarly we'll be replacing all the 3-year returns and 5-year returns with their mean values as well. So let me execute this. Now let's look at how our data is right now. So if I look at all the null values, now we have 0 null values in each of the columns, which means we have entirely eliminated all the null values present in our data set. So now that we have eliminated all the null values, let's start by doing our exploratory analysis. So initially let's do a classification type exploratory analysis, or maybe let me put it as okay. Now that we have eliminated all the null values, let's start with our exploratory data analysis. So firstly, we'll just look at the categorical data analysis. So coming to categorical data analysis is somewhere where you do analysis on categories. So particularly in this data set, the categories may be something like your AMCs, which is asset management companies, or maybe the categories such as where the investment is being made, like either equity, hybrid, solution oriented, others, or debt as well. And so we'll just have a look at that. So for that, firstly we need to get all the columns which do not have numerical values. So something like this: the scheme name, the fund manager, Sortino, and all those stuff. So let's do that first, and then we'll just have a look at the values as well. So now here we can see all the values, which has only the object types over here, as you can see. Now we'll do some analysis on this particular the category columns. So let's first initially explore how many AMCs have been are present over here. So let's execute this command. So as we can see, ICICI Prudential Mutual Funds is the highest number of entries in our data set. So they have 57 schemes, and Aditya Birla stands second with 49 schemes, and SBI with the third. So also let's look at the category of investments being made by each of these AMCs and see how many particular schemes are investing into each category. So here equity is the highest, where 308 schemes are doing their investments in equity, and debt is the second highest with 282 schemes investing in debt. So let's also look at the fund managers who are managing these assets. So fund manager column with their value counts. So here Rohit Sexaria is the fund manager with the highest mutual fund management, and then comes Deepak Agarwal with 12 schemes, who is managing 12 schemes. So next let's just drop a few columns, because as we can see here, we already have category and AMC names, and I guess the subcategory and scheme name is not relevant for us, because each of the scheme name is very different and unique for each of the AMC. And since these are unique, it's not practical to analyze these stuff because they are too arbitrary. So let's do that first. So let's just copy each of these stuff using the following command. So which is category column is category column dot copy, which will copy all the stuff which was there in cat call to cat call again. So next we'll just drop each of the subcategory and scheme name values. And after doing this, let's have a look at how our cat call looks right now. So let's do cat call dot head. So now as you can see, we have eliminated the other two columns which was present here. As you can see, the scheme name and subcategory have been eliminated. So now coming to each of the category of fund distribution, let's see a plot over here. As you can see, initially I have imported matplotlib's pyplot as PLT, so we'll use that for plotting, and we'll be using Seaborn as well. So how to plot the distribution of fund categories? So let's come up here. So as you can see, there is equity 308, debt 282, hybrid 116. So we'll declare all these in a particular array. So let's do that using values is equal to, let's declare an array. So we'll give 308, 282, 116, 80, and 28. And after declaring this array, let's do a pie chart so that we can have a clearer outlook on what's happening. And then we'll set our plot's title, and then we'll display it. So let's hit execute. And now as you can see, this is the categorical distribution of the funds. Next, we'll do some analysis on the numerical parts as well, now that we have finished with the categorical analysis. So here, since last time we excluded all the numerical values, this time we are excluding all the object values. So let's look at how our number columns looks like. As you can see, this is how our numerical columns are looking like. So we can just do a descriptive analysis over here. So something like this. So looking at the count, standard deviation, mean, etc. But I am more focused, so that is beyond the scope of this video. So we'll just have a look at some brief business outcomes which we can understand from this. So let's concatenate this numerical columns with our initial non-numerical columns using this, and let's have a look at that, the result of what we get. So now, as you can see, we have all the numerical columns, along with that the fund manager, AMC, and category concatenated to this. So now let's have a look at some statistical data. So first up, we'll just look at the highest returns of any fund which exists. So firstly, we'll just find all the 1-year returns with the ID max. The ID max will return the highest return over here, and then we'll just have a percentage of that returns, and then we'll print it. As you can see, the Bank of India mutual fund, which had invested in the category of debt, had the highest returns in 1 year, which is 130.8%, which is an absolutely high value. Let's also see which particular fund has returned the minimum returns in one particular year. So just let's just copy paste the same thing and do it for minimum. So here, instead of ID max, we'll just put ID min, and let's execute this. So before that, okay, now let's execute this. So as you can see, the ICICI Prudential Mutual Fund AMC, which invested in the category of equity, had the lowest returns of minus 19.7%, which is a loss basically. So similarly, you can do this for the 1 year and 3 years and 5-year returns as well, using the same thing, but instead of the returns underscore 1 year, we would use the respective column name, which is returns underscore 3 year or returns underscore 5 year. So this sums up our coding tutorial. I hope this was informative for anyone who is interested in data analysis using Python. Hope you had a great learning journey here, and I wish you all a good learning journey ahead. So the description for the dataset and the notebook will be provided in the description. So please feel free to refer that in case you ever need any reference. And you can also comment on the comment section if you have any doubts regarding this. So thank you. Have a great day. Signing off.